Alright, we're continuing with this part C again. So this is kind of, we broke part C into two parts. So this is the second half. We are going to do a little factoring. You say, I thought we already did tons of factoring. How much more factoring can we do? But what's the stuff that we've been working on in this 1/6? What kind of exponents? Negatives and fractions. That's right. Okay, so we're gonna factor some things that have negative exponents and or fractional exponents. Okay, but let's go back to the beginning. Let's go back to a real simple problem. Just trying to make this up here. So let's say we have 3x to the 5th plus 9x to the 2nd. I'll make this as easy as I can. Minus 12x to the 4th. Okay, I think that's good enough. Let's look at this. And I want to factor this thing, right? So is it one of our special type of factorings, like a trinomial? I mean, it is a trinomial, but is one of those regular factoring trinomials? Is it a difference of two squares? Is it a perfect square? Is it... Yeah, all it is just the greatest common factor factoring. You're exactly right. Okay, so that's what we're going to do. So you see if there's anything in common with all of the terms. Is there?
3x
yeah, 3. There's a 3, right? And then there's a what? X squared. So what did we do? We took the numbers, and we took the number that will divide into all three of these numbers, right? What's the largest number that divides evenly into all three of those numbers? That would be 3. That was easy. What about the x, though? Which one did we pick? We picked the x is the lowest one. Exactly right. Now that's a key right there. Okay, the whole reason I'm doing this little easy example before we get to the new stuff is to understand that which one did we take? We took the smallest, didn't we? The smallest exponent, because that's the one that goes into everything else. Everybody understand that? The smallest number. All right, remember that. So then, when we factored, what did we do? We just took this and we divided it by 3x squared. Okay, this divides into, or we say it goes into. A lot of times we get a little lazy. Instead of saying dividing into, we say it goes into. All right. So what is this? 3 divided by 3 is 1. X to the 5th divided by x squared is x cubed. Plus 9 divided by 3, 3. X squared divided by x squared is
0.
No.
Or 1.
It's 1, isn't it? 3 times 1 is 3. So I don't need to put any x's there, do I? Put a minus. What about this? 12 divided by 3 is 4. X to the 4th divided by x squared is x squared, not 2. X squared. And that's how we factor. That was pretty simple, wasn't it? That's way easier than some of the factoring we've done this year. That was one of the easier ones. But let's now try one that's maybe has some negative exponents. So let me find an example here. There we go. So it says to factor, right? So it's 12 x to the negative 2nd minus 8 x to the negative 3rd. Alright, and the problem says to factor. Now, remember what we talked about on that last one, and the same rules apply. Just a little bit trickier because of the negative exponents. You probably never factored negative exponents in Algebra 1. Maybe not even in Algebra 2. Okay, I taught Algebra 2 several years here, and I don't think we ever factored with negative exponents. So this is still the same basic idea. It's just taking it up a notch. All right, that's all this is. Let's take a look. Look at the regular numbers, 12 and 8. What number divides evenly into 12 and 8? 4 does, right? So 4 is my common factor with the numbers. That was easy. That's just normal, right? Now, what about the x's? Now remember, which one did we pick before? We picked the lowest one. Whoops, went a little too far on that one. We picked the smallest one, didn't we? Which one is the smallest one between x to the negative 2nd and x to the negative 3rd? I got a... Who says to the negative 2nd? Raise your hand. Who says to the negative 2nd? Be bold. Come on. Come on. Okay, I got about 4 or 5 of you. Okay. Who says x to the negative 3rd? Okay. Because if you look at your number line, all right, there's 0, right? There's negative 1. There's negative 2. Where's negative 3? Which one's the smaller number? Negative 3 is a smaller number, okay? So negative 3 is actually the smallest number. Okay? Does that make sense? So that's the one that we pick. We pick the smallest one. That's where it gets a little confusing because you see 2 and 3 and you think 3, that's not smaller. But it's not a 3, is it? It's a negative 3. Negative 3 is smaller than negative 2. Make sense? All right, so let's factor that out. Let's pull that out of there. So it's x to the negative third. Now, what's the rule? What do we do over here? We took this first one, we divided it by our greatest common factor. What do we do here? Take this and divide it. The first part's easy. 12 divided by 4 is what? 3. Okay, it's this next part that can be a little bit tricky. It's x to the negative second divided by x to the negative third, right? So what's the rule? Look, what do we do with the fractions, or what do we do with the exponents here? We subtracted the fractions, didn't we? We went 5 minus 2 to get 3. We went 2 minus 2 to get what? 0, right? And x to the 0 is a 1. We went x to the fourth. We went 4 minus 2 to get 2, right? So what are we going to do here? We're going to go what? Negative 2 minus what? Negative 3. Okay, so it's plus 3, isn't it? So it's negative 2 plus 3. What's negative 2 plus 3? It's positive 1. So this is going to be x to the positive 1. All right, a little bit tricky. It's the same process, isn't it? It's the same exact process as what we did here, but the numbers are a little bit tougher because they're negatives, and you have to think a little bit more than what you had to up here. You okay so far? All right, minus. All right, let's do this division. 8 over 4 is 2. Now this one's easy. X to the negative third divided by x to the negative third. Anything over itself is what? It's a 1, so it's 2 times 1, which is just 2, and that's your answer. Okay, now it's factored. How can you double check to make sure you did it right? Distribute, that's right. Let's distribute it out just for fun, just to see if we got it right. It doesn't take that long. 4 times 3 is 12. X to the negative third times x to the first is x to the what? Negative second. That does work, doesn't it? Minus 4 times 2 is 8. X to the negative third. Yep, it distributes, and everybody's good, right? Does that make sense? Okay, good. Let me find another one before I... Tell you what, let me go to some of these problems. I think we need to do one more of these, don't you? Oh, you know what the nice thing is about this worksheet? Is they didn't need to do this. I almost wish they didn't, but you'll probably be glad. They actually tell you, they tell you what the greatest common factor is. Look at your worksheet. Do you see it?
When I saw it last night, I was kind of wondering why there was a separate factor.
Right, because they put a little semicolon in there. Do you see that? And they actually tell you what the greatest common factor is. All right? They kind of make it easy. They take half the work out of it, don't they? So here's... Let me find a good problem. These are all like a little too easy. I'll tell you what, let's do this one. Okay, let's change colors from that puke green to let's go to this nice orange. Here we go. Ready? P plus 4 to the negative 3 halves plus another P plus 4 to the negative 1 half, and then plus P plus 4 again in parentheses, and that is to the positive 1 half. And what they do is this. They put a little semicolon right here, and then after that they put P plus 4 to the negative 3 halves. So what they do is they say this. Here's the instructions. It says factor using the given common factor. So what do you think the given common factor is? To the negative 3 halves, right? Okay, so that thing right there after the colon, they're actually giving it to you. They're giving you the greatest common factor. That's nice of them, isn't it? But you could have figured that out anyway, couldn't you? You look at it, which one do you take for the greatest common factor? The largest? The smallest one. Okay, it's technically the smallest one because negative 3 halves is negative 1.5. That's the smallest number out of these 3 exponents, isn't it? All right. So they told you what the greatest common factor was. So that was nice of them. So let's do that. Let's factor that out, and let's see what's left over. Now, what do we have to do to that greatest common factor? Take all these things and then divide, right? So let's do it. Let's take this and divide it by our greatest common factor. Well, it's exactly the same number. So what's anything divided by itself? It's just a 1, isn't it? Okay, put a 1 there. Plus, let's take this, divide it by the greatest common factor. So what's the rule? What do we do with the exponents? Subtract. That's right. So let's, if you can't do it in your head, write it on the side of your on the side of the problem or something. So what is it? It's negative 1/2 minus what? Negative 3/2, right? Take the exponents, I subtract the exponents. Negative 1/2 minus a negative 3/2. That's a plus. What's negative 1/2 plus 3/2? 2 over 2. Now it's not 4, it's negative 1 plus 3, which is 2. 2 over 2 is a 1, right? So that's our exponent, isn't it? So I put p plus 4 to the first. Do you really even need the? No, don't even need it, do you? In fact, don't even need these parentheses, do you? Because it's not even being taken. It's only being taken to the first power, so you really don't even need that parentheses. All right, let's do the next part. Put a plus. What do we do here? Subtract. So it's 1/2 what? Minus negative 3/2, which again goes plus. Now it's positive 1 plus 3, which is 4. 4 over 2 is 2. So this is p plus 4 to the second. My guess is they don't keep it like this. I don't even have the answer key in front of me. All right, I just have the problems. But my guess would be this, that we simplify the stuff inside of the parentheses. And we really should do that. Right off the bat, I see something. I see that 1 and 4, don't you? Okay, now look at this. This is going to give you p squared plus 8p plus 16. So that p in there, this 8p, has got to add with this p right here. So yeah, I do need to simplify this. So let's just add what we can add right now first. So 1 plus 4 is 5 plus p plus. Now, you may be able to do this in your head. If not, go off to the side and multiply it by itself. It's not just p squared plus 4 squared, is it? Because when you square something, you multiply it by itself. So you got to do this stuff. So what is that? That's p squared, outside inside, which is 8p, and then the last, which is 16. So let's write that down. Plus p squared plus 8p plus 16. Alright, this never changed, did it? This thing on the outside. So we keep it like this. Now let's simplify inside of here. Let's do the highest power first. P squared. Can I add p squared to anything else? No. What about the p's? Yep. 1p plus 8p is 9p. And then we can add the regular numbers. 5 and 16 is 21. Okay. And, problem says to factor, right? Does, no, it doesn't factor anymore, does it? Because 7 times 3 is 21. That adds up to 10. Doesn't add up to 9. So that doesn't factor, does it? All right. Yeah, because there's nothing else, right? 7 and 3, that's it. So that doesn't factor anymore. So that's my answer right there. So that's the simplified answer. Wow, you thought you were done after factoring all that first stuff, right? But then you looked at this. See all that stuff right there? You had to look at it and say, can I simplify it? Will I get things that add up? Will I get any like terms that add up? And if you look at it, you're like, yeah, I will, because that 1 and 4, that adds up, so I got to simplify that. I see a p, and look at this. I look at this, I'm like, oh, wait a minute. If I multiply that out, I'm going to get a p term right there, and it's going to have to add to this. So, might as well multiply them out, add up all my like terms, look at it one more time. Okay, look to see if that factors anymore. I looked at it, and I said, nope, 7 times 3 is 21, but 7 plus 3, if I add them up, is going to be a 10p. That's not a 10. It doesn't factor anymore, and I just leave it like that. Okay? Let's do one with a fraction. Okay, we did negative exponents. Enough of that. Let's do one with fractions as an exponent. Again, same idea. We'll start off pretty easy here. 4m to the 1/2 plus 3m to the 3/2. And we want to factor this. Okay? What about the actual numbers, 4 and 3? Does anything in common divide evenly into 4 and 3? No, it doesn't. What about the letters? I got an M here and an M here. Which one do I pick? Oh, they actually tell you, don't they? But let's pick it anyway. Just for fun, let's just pick it ourselves. What's the greatest one? M to the 1/2, right? We take the smaller one, right? So 1/2 is smaller than 3/2, so that's what we pick. So the greatest common factor is just m to the 1/2. Okay? Now how do we figure out what goes in this parentheses? Well, we take this, 4m to the 1/2, and divide it by this. Remember, this is a 1 out here, isn't it? 4 divided by 1, that's just a 4. What's this? M to the 1/2 over m to the 1/2. Well, it's not nothing. It's a 1. It's a 1. Okay, so 4 times 1 is just 4. Okay, you're right. I know what you're saying. You don't have to put anything here, but technically it is a 1. Okay, 4 times 1. Put a plus. Now, what's this number going to be? 3, right? Because 3 divided by 1. And then watch this. M to the 3/2 divided by m to the 1/2. What do we do with the exponents again? We subtract the exponents, okay? That's what we do with a division, isn't it? We subtract the exponents. So 3/2 minus 1/2, should be able to do that. What's that? 2/2, which is 1. So it's 3. That's our exponent, isn't it? So you still got to put the m there. M to the first, or just 3m. And that's your answer. You don't need that 1 there, do you? Okay. That wasn't so bad, right? Doesn't it follow the exact same rules as what the other factoring did? Yeah, except you got negatives now and you got exponent, or you got fractions as exponents, and it just makes the arithmetic a little bit trickier, but the process is exactly the same. It's no different. Now you want a harder one than that, don't you? Sure you do. So let's find one. I'll tell you what, we'll do one of those with the parentheses thing. Remember that p plus 4 problem we did before? Oh, we already did a fraction one, didn't we? I didn't even think about that. I was thinking the negatives. Yeah, look, we already did a fraction one. Yeah. So we're good. I didn't even think about that. That's weird. So that was fractions and negatives, right? So if you can do this deal right here, you can do any of these. Yeah, that's it. I think we're good. I think we're good. All right. So what's the worksheet then? It's like 5 to what? What's the end of it? To what? 10? Okay, so we're doing 5 to 10, just finishing it up, and that's what? Section 16C, right? That's supposed to be a 5 right there. Crazy 5. All right, so finish those up. That'll be due tomorrow, and we'll do one more worksheet from 1/6, and we'll be finished with 1/6. Took us like a week, didn't it, do this thing? That's okay. All right, that's it.